Hello, Latin geometry students. In this assignment, we are going to talk about midpoints and bisectors as they show up in proofs. So first off, a midpoint. Midpoint is just a point in the middle of something. And when we say it's in the middle, that means it cuts it into two equal halves. For example, here's a segment. If this point is the midpoint, that means that if the original segment had a length of 10 units, then each of the two little parts are now have a length of 5. Now, we don't always do this in geometry with numbers. Sometimes we just say it's the midpoint and you don't have any measurements. So instead, we just put in tick marks indicating that this side and this side are congruent to each other. When it shows up in a diagram, you'll be told something like, you'll have a picture, something like this maybe, and it'll say C is the midpoint of a segment, or some other point is the midpoint of some other segment. When you have this, the first thing you want to do is identify that point here. We're identifying point C right here as the midpoint. And then the common mistake is people make it the midpoint of the wrong segment. You have to make sure to read which segment it is that you're supposed to be looking at. In this case, segment AE is this segment. So this segment is cut in half by point C. That means the distance from segment AC and the distance to EC have to be the same. As it shows up in proofs, we'd have a proof, and this is the same picture. We're going to prove these two triangles are congruent using the midpoint. So first thing you want to do, as in any proof, is we want to start with the given information. It says segment BC is congruent to segment DC, so we would mark that in the picture. BC and DC are congruent. And the next thing it says is point C is the midpoint, that's our abbreviation for midpoint, by the way, of segment AE. So this point here is the middle of this segment. So that's one thought, and then you say, oh, if it's the midpoint, then these two parts are congruent to each other. It's important to realize that those are two separate thoughts. One thought, that it's the midpoint. The second thought is that these two segments are congruent, because in our proof, it'll take up two lines, and those will be our two lines. So back to the proof. If we look at the picture, that's all of our given information. What else can we add to this picture? Well, these two angles are congruent because they're vertical angles. And then if we look at our two triangles, these two triangles are congruent. This is an example of side, angle, side. Two sides congruent and the included angle. So then all we have to do is take that and put that into words for our proof. Our first statement, as usual, let's just use the given for our first statement. We can say segment BC is congruent to segment DC. And the reason is that it's given. Line 2, the other part of the given information, C is the midpoint of AE, and our reason, also given. Now, we said C is the midpoint. We didn't say these two segments are congruent yet, because that's something we figured out from the midpoint. So the next thing we can say is that if C is the midpoint of AE, then AC and EC, those are the marks we put in there, those two segments are congruent. And the reason for that is going to be the definition of a midpoint. If we're told something's a midpoint, then we know the two halves are congruent. That's the definition of a midpoint. Finally, to finish off the proof, the next thing we included is that these two angles are congruent. What's the reason for that? Those are vertical angles. And finally, we can tell our two triangles are congruent, and that's what we're trying to prove up here. So our two triangles are congruent, and the reason for that is side, angle, side. Now, once again, when we talked about the midpoint here, it took up two lines in our proof. One line is being told, hey, this thing is the midpoint. That's what we were told. From that, we figured out that these two segments are congruent because that's what a midpoint does. That's the definition of a midpoint. Anytime you're told something's a midpoint and you're going to use it in a proof, it's going to take up at least two lines in the proof. One, stating that you know this is a midpoint, and then two, here's the things that are congruent to each other because that's the midpoint. Now, these two lines have to go together. You could mix up some other parts in the proof. You could make these two your first and second lines in the proof, and then do these segments are congruent given, and these angles are congruent. So you can mix them around, but these two have to be in this order. And all this other stuff has to be figured out before you can say the triangles are congruent by side, angle, side. Next, we're going to talk about a bisector. A bisector works almost the same way as a midpoint. If you forgot what a bisector is, it cuts something in half. See, a midpoint is only the point in the middle of a segment, but a bisector can cut other things in half. You can cut in half other segments, or more commonly is we're going to be talking about cutting in half an angle. So here's an angle. If we tell you this angle measures 50 degrees, and this is the bisector, then because this thing's a bisector, by the definition of a bisector, we're going to create two angles that are congruent to each other that are each half of this. In other words, we'll get two 25-degree angles here. Now, usually when we're doing these in proofs in geometry, we don't have the measurements. So instead of having this with all the numbers, we would just put in these tick marks. If this is a bisector, then these two angles are going to be congruent. So when it comes on terms of a proof, a picture might look something like this, and we'll be told that AD, that's this line down the middle here, is the bisector of angle CAB. That's this angle up top. This line, or this segment, pardon me, cuts this angle in half. So in our proof, we'll have to use this, like with the midpoint, it'll be two lines. One line will say, this is the bisector, because we were told that. And then the next line, we can say, these two angles are congruent, because that's the definition of a bisector. So here's an example of our proof involving this. As always, the first thing to do in our proof is to mark the given information. Angle B and angle D are congruent. We put those marks in. And now, AC bisects angle BAD. That means this line down the middle is cutting this angle on top in half. So that means these two angles will have to be congruent to each other. Again, that will take up two lines in the proof. One line saying this is a bisector, and then another line saying that these two things are congruent by the definition of a bisector. All right, once we have that information, what else can we add to this picture? In this case, we know segment AC is congruent to itself, and that's going to be the reflexive property. Now, if we look at our two triangles here, triangle on the left and right, these two triangles are congruent. What's the reason for this? Well, we have two angles on the side. You have to decide if the side is the included side or not. So is it going to be angle, side angle, or is it angle, angle, side? All right, then we go in for our proof. And again, for our proof, we'll just start with the given information. Angle B is congruent to angle D. Reason? Given. Second piece of given information, segment AC bisects angle BAD. Reason for that? Given. Now, what else did we do? Well, we know that since this is a bisector, we have these two angles are congruent. So we can say angle BAC is congruent to angle DAC. The one on the left is congruent to the one on the right. What's the reason for that? That's the definition of a bisector. Finally, what else did we add to this picture? Well, we added the circle here indicating that segment AC is congruent to itself. So AC is congruent to AC, and anytime something's congruent to itself, that's the reflexive property. Finally, we said the two triangles are congruent to each other, and that's what we were trying to prove. And the reason for that, angle, angle, side. And once again, note that when we talked about a bisector, it took up two lines in the proof. One line, we're told this is a bisector, that was given. The second one, now these angles are congruent because that's what a bisector does. Okay, so we're going to talk about one more proof, each one with a midpoint, one with a bisector. Here's this one. All right, so again, start with your given information. Angle A is congruent to angle D. You want to mark that in the picture. Since O is the midpoint of AD, that means this segment, AO, and this segment, DO, are congruent. That'll be by definition of a bisector. What else can we add to this picture? Well, angles 1 and 2 are vertical angles. Those will be congruent. So if we look at our two triangles, they're going to be congruent. This is an example of an angle, side angle. So take a second and fill out the reasons for this proof. So our first statement, angle A was congruent to angle D. We knew that was true because it was given to us. The second line, it's got a blank and it says given information. Well, there's only one other piece of given information, so we can use this. O is going to be the midpoint of AD. Now, once we knew that O is the midpoint of AD, what did we figure out using by definition of a midpoint? It's that segment AO and segment DO, or OA and OD, are congruent. And we got two lines left in the proof. We know our last line is going to be what we're trying to prove. So what else did we add to this picture? Angle 1 and angle 2 were congruent, and the reason was vertical angles. Finally, we could say our two triangles are congruent, and the reason for that was angle, side angle. Okay, and our last proof here, again, we'll start with taking our given information into the picture. QT bisects angle RQS. So this angle right here is cut in half by this line down the middle. That means these two angles are going to have to be congruent to each other. That'll be by definition of a bisector. We're also told that angle R and angle S are congruent. So those two angles are congruent. What can we add to this picture? Well, the center segment's congruent to itself. As always, that's a reflexive property. And if we look at our two triangles, these are both examples of angle, angle, side. It's angle, angle, side because the side, down the middle here, is not the included side. It's not the one between the two angles. So we come over to our proof and just try to fill in the information. And it's a little bit out of order, just to see if everybody can adjust to it. The first statement is angle R and angle S are congruent. That is given to us. The second line says something is given. Well, we only have one other piece of given information. QT bisects angle RQS. That's our other given information. We use that information, that the QT is a bisector, to figure out that angles 1 and 2 are congruent. What's the reason for that? That's the definition of a bisector. Now, segment QT is congruent to segment QT. That's the line down the middle is congruent to itself. As always, that's the reflexive property. Next, our two triangles are congruent. All right, you got to name this triangle in the right order. Triangle QRT. So top left bottom is going to be congruent to top right bottom. So it should be triangle QST. What's the reason for these two triangles being congruent? This is angle, angle, side. Finally, it didn't say to prove the triangles are congruent. We're trying to prove these two segments, RT and ST, the bottom ones. Why are these congruent? Well, since the whole triangles are congruent, then these parts have to be congruent. What's the rule that says that? That's CP, CTC.